Okay, like here now, this is two independent events. Okay, but right here, this is more than two events. Now, when we talk about two events, we talk about independence. But when we talk about more than two, we talk about mutually independent. Mutually independent. Okay. Now you're actually going to see what do I mean by mutually independent for instance for three events, mutually independent for three events. This must hold. Not only that, this must also be independent. This must also hold. Now, when I have three events, right? Okay, for them to be mutually independent, this must hold and this must also hold. In pairwise, this have to hold, and for this have to hold. Now, if I want to generalize, okay, when you take a look at this guy now, okay, now if I okay, let me use this opportunity to appreciate those who provided the feedback. Of course, initially, I normally use this because thinking that the camera will only focus on this and this, but somebody in this class provided a feedback that why can't we use the whole board? Okay, and I contacted the Unite, and they say, oh, they will be able to, camera the whole thing. So today I'm gonna be using the whole board. So make sure you always send me a message, okay? A live feedback. Okay, now if I have A1, A2, okay, and uh, you know, maybe that goes indefinitely, okay. Now, do you know that if I want to write probability of A1, for instance, let's say that maybe I stop at AK, okay, the probability of A1, A2 until I get to AK, okay. If I actually, so what I want to do is I want to find the intersection of all of these. Now, writing that in short form, okay, is what you see here. That's another way, if I want to write that in short form, okay, I start from 1 to K. So this is a way to write this in short form, okay? Now, if that is a way to write that in short form, and you know that I said, if for two events, I have this multiplied by that, okay, then for multiple events, A1 intersection A2 intersection dot 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 intersection AK, we actually gonna have this multiplied by this until you get to AK. Now, if this can be written in a short form, okay, as this, I start from 1 to K. Okay, now this, how can we write product in short form as well? So product is going to be pi. This is a product. Okay, P-A-I. Now, you know what this guy is representing this. So this is a shorter way to write that, and this is a shorter way to write that. Okay, this is still defining independent. Okay, so now, if I want to talk about conditional independence right now, okay, the mutually independent right now, okay, I first say that all the pairs, take a look at the first one, all pairs, just like what I said here, okay, I only consider this because I only have A1, A2, A3. What if I have so many? If I have so many, okay, I'm just going to write that, okay? The PAI intersect AJ, Okay, it's going to be equal to that for all ij. Go ahead.
For in the middle there, for all finite subsets J, what is that symbol? It looks like the subset deal, but it's got a line under it.
Oh, this is the same thing as I. This I lies in J. J is like a set, and I is a member. Does that make sense? So that is what it means. Does that make sense? Yeah. Okay. Now, that is the first condition, and this another one. So you see that for the three, and you do know what we are zooming here. The example here is focusing on 4 events. If I have 4 events, okay, pairwise, they have to be independent. Then when you consider them in threes, they also have to be independent. And lastly, when you consider the O4, they have to be independent. So that's what it means. Okay, that's exactly what it means. Now, that will lead us to continuity theorem. Now, in continuity theorem, okay, you actually have A1, A2, and so like that. They are increasing sequence of events. Okay, increasing sequence A1, it's an improper subset of A2, and so on like that. Okay, now if we have this and we want to figure out limit, because we figure out limit when it comes to sequence. So the probability of the limit of an, and I say n could be 1, 2, an is a sequence. I mean A1 to, you know what I mean? So the probability of the limit as n tends bigger, at n tends to infinity, means as n tends bigger, can be written as the limit of the probability A itself. Okay, this is just this is just rules. Okay, we're still going to apply all of that later. But you know what? I want us to quickly come to the total law of probability and Bayes rule. Of course, yesterday I introduced you to this, and there's a connection, between the Bayes rule and the law of total probability. So, in the Bayes architecture, the total probability is occupy the denominator position. So, today, you know what I'm going to do? I'm going to walk you through application of this in real life. Of course, I'm going to touch medical diagnosis. I'm going to touch forensic science. I'm also going to touch quality control. Then I'm also going to touch some other areas as well. Okay, but let's get started with this. Now, yesterday I introduced you to Bayes theorem. Okay, situation where we got two categories, where we have events, and the event can be partitioned into B and not B. Not B is B complement. Of course, the Bayes theorem is going to be this is a Bayes formula. Now, I want you to pay attention because I want to walk you through this. What is the essence of a Bayes rule? Now, if you take a look at what I have here, okay, the probability of B given A, we actually call that posterior. But the whole thing did not start from that. The whole thing actually start from this, which I'm going to show you, right now. But for you to be able to understand this particular formula here, right? I think I first need to walk you through the area of application of Bayes rule. Now, let's talk about Bayes application, okay, in real life. Okay, Bayes application in real life. Okay, now Reverend Thomas Bayes, 17, Reverend Thomas Bayes, was